Okay, we're on Ceva's theorem. Ceva theorem states that given any triangle, let's say triangle PQR as shown below, the segments from PQR to the opposite side of the triangle are concurrent if the product of the ratios of the pairs of the segment formed on the sides of the triangle equals 1. So we are just saying, this is just grammar. We are saying that if you have a triangle such that this point this line, this segment passes through the same point V, then the ratio, the product of the ratio P x over SQ times QU over UR times RT over TP must give us 1. So that's Ceva's theorem. So we'll prove it. So I'll divide the proof into three pages so that you understand. You first understand why I have to do what I'm going to do, so make it easy. So we'll call here A, we'll call here B. So let's add an auxiliary line running from P. So do you see the auxiliary line? So that's the height. This is our height. The height of the two triangles. So that's our height. So we'll draw a line that is perpendicular to the basis. So this is the height. So looking at this, we see that the area of area of triangle PQU to that of triangle PRU. So what's area of a triangle? Half base. So the base is A, while the height is H. The same half, but the bases are different. So what do you know? They have the same height. So the answer will be A over B. Okay, since we've noted from the first diagram, so let's call this, okay, we've called here A1, A2. So let's call this A3, A4. The sides are, the length here is A and the length here is B. So since from what we've done from the other diagram, we'll see that we've noted that A3 over A4 is A over B, yes, from what we've done. And also we've noted that if you look at this now, one triangle, another triangle, that's A1 plus A3, that's the triangle PQU over A2 plus A4 will now be A over B, yes, because it's now one triangle. If you remove this line, this is another triangle which looks like this, A3 over A4. And remember, this is ratio of area, not the actual area. So if we can call this the actual area of A3. Let it be AX, while that of A4, let it be BX, yes, which is the same. The common term here is, or common factor is X. And let's call this AY. Let it be the actual area, A1 plus A3, let it be AY, while that of this BY. So what do you have to say? Therefore, if I want to get A1 over A2, that's this part. If I want to get this, you see, it means A1 A1 plus A3, yes, minus A3. The same thing if I want to get A2 is A2 plus A4 minus A4. Yes, we are correct. So this one area. So what's the actual area of A1 plus A3, which is AY? This is the actual area. This is just a ratio, but the actual area is this AY minus A3 is what? AX, the actual area, over that same, this is BY, the actual area. Why the actual area here is BX. So what do you notice? We have a common factor here, which is factor 8. This is the remaining is y minus x. Why the remaining here is, that is factor b. So what do you have to say? We can see that a1 over a2 is a over b. Yes, because this is gone, the common factor. So that's okay. So from based on what we've done before in the other video on the other page, let's say here a, b, c, d, e, f. So we can see that if I decide to wipe let me wipe here so that you see it as the other one. So what do you see? Therefore the area, if the ratio of area of triangle P PQV over ratio of triangle P, area of triangle PRV will now be A over B. Yes, check what we've done before. So this area now to this one will now be A over B. Okay, so let's wipe what we've done before. Let's just wipe this. Okay, so that same way, if we decide to wipe this one, so if we now do area, ratio of area of this triangle, this one to this one, so which is triangle QRV over triangle QPV, triangle QPV, we see is now C over D. Check. C over D based on what we've done before. We'll wipe this. Do you see it? This ratio, the ratio of area of this and this, now the ratio of the sides. So okay, let's wipe again. So let's check. We've done this. Let's do, if we wipe this one, and this, so let's check ratio of area of triangle RPV to the ratio of area of triangle RQV. So do you see it? Check. We've wiped here and here. So the ratio of area of that is E over F. So let's do something. Let's try and multiply this Therefore, we see that if so, let's repeat this. So let's look at the left hand side. We see that we can see that this is 1. Yes, this cancels this. Check. PQV, PQV, check. RPV, PRV, this. So the answer is 1. So it's 1. We've proved that the product is 1. So that's Ceva's theorem for you. We've proved that. Let's use it and solve a question, just one question. TP. So looking at the diagram, you will notice that we are given the segments of each of the sides of the triangle. So we're going to use Ceva's theorem. Yes, Ceva's theorem states that if you have a triangle like this, then the ratio of the product of the ratio of the sides, the segments, is equal to 1. That I'm saying that px over xq times qu over ur times rt over tp is equal to 1. So I've proved it before. Ceva's theorem. So we are given orders, but we are asked to find TP. So we substitute. So we can see that PS is 10 over SQ is 5 times 6 over 18 times 9 over TP is equal to 1. So this is 2. This is 1 over 3. This is 2. This is 1 over 3. This is 9. We move this to the other side to be TP. That's making it the subject of formula. TP times 1 is TP. So what do you notice? My answer is 6. So the answer is option B. So the solution is based on Ceva's theorem.